Hello everyone, welcome to SuperGeo webinar. I'm Sarah Liu, the Sales and Marketing Director at SuperGeo. And our product specialist, George Wang, is the main speaker today.
Hi everyone, I'm George.
Here we also have our product team who will help answer all of our questions during the webinar. Today, we will talk about how to facilitate field text by mobile GIS applications. As you know, mobile GIS changes the way we capture and update field data. Geospatial information can be collected quickly with better efficiency and accuracy. In case you are new to SuperGeo product family, you may see from the slide of our GIS provision. Superpan, the full-function mobile GIS, will be our main target today, while the desktop and the server software will also be mentioned for the integrated GIS workflow. To give you a brief understanding of Superpan, here is the main features. Superpan is a feature-rich mobile GIS software. It's especially designed for field survey and data collection, and it's compatible with Windows Mobile ruggedized mobile devices and tablets working on Windows PC OS such as XP 7 or Windows 8.1. So let's give you a quickly overview of Superpan. Superpan allows the users to capture and edit the geospatial data in an efficient and accurate way. Later on, George will tell us how. And you may display and you may do the on-the-screen measurement query with the data very easily. Also, you may update and synchronize the spatial data, collect in the field, and update in the server. When you have the 3G or Wi-Fi connection in your devices, you may synchronize the data back to the server side in real time to achieve very efficient data update. So let's have a quick review of the interface of our Superpan software. You may see from the interface that it is very user-friendly. We use two levels of the toolbar. So you may see we have something like a file management, some editing tools, or GPS functions, and some customized tools. You may start them when you want to use that. So when you click on a specific toolbar, the following more detailed function will be pop up. So you can choose it. For example, you want to edit the polygon, or you want to see more GPS accuracy information. And also on the new version of Superpan, we can see that two informations are here. For example, this is average satellite numbers, and this is the accuracy of your hardware. So if the surveyor would like to know if the GPS or satellite information is strong enough to have a good quality survey, you can wait for the information and until it's fulfill your request. Also, you can see from the right side of the other image that it is not English. So we support 13 other languages on the user interface. For example, we have more users today from Latin America, so Spanish and Portuguese are supported. And we have also French, German, such as different kind of European languages. So no matter where you are, we provide localized user interface for your easy use. Lastly, let's take a look at the data. The supported format of Superpan include shapefiles, geo, raster data like GIF or JPEG, etc. And we also support the users if you have archived before and you still kept your archived files such as APM. So it's also easy for you to seamlessly import it into Superpan and start your editing work. One Superpan software includes two licenses, PC and PDF version. So it's easier for users to prepare the maps in the office, and when you would like to do the field survey, you can install the PDF license in your handheld devices. Use the GPS to collect the data. So one price, two licenses. Okay, this is the overview of the Superpan, our main target today. For the users who like to ask any questions, just click on the question panel. Or if you are shy today, it's okay, you can drop us an email. Finally, we'd like to thank you to join us today. So we will choose 10 attendees today randomly, and we'd like to give away a Superpan license for free. So stay tuned with us. Now let's welcome George for more introduction. Thank you.
Hi everyone, this is George. And today I'm going to mainly introduce the mobile GIS, and it is a portable GIS system which is helpful for your field work, especially when integrated with other GIS products such as the server GIS or desktop GIS and web GIS. So for example, if you have all these GIS products and working together, you can use the mobile GIS to collect data in the fields, and after the field survey, you can synchronize the data to the server. So people, whether they are using the desktop GIS or web GIS, they can see the synchronized data in real time. So today I'm going to mainly introduce the Superpan, which is one of our mobile GIS solution, and also we are also going to introduce the SuperGIS server, which is our server GIS solution, and the SuperGIS desktop, to show how these products can work together to help your field survey. So now, today we are going to begin with a story. Imagine that you are in a wild wolf survey team, and you are going to survey the location of the wild wolves. So you will need to record down the spots where you see the wild wolves, and also you have to record down their habitats. And also you can build up an online GIS platform to manage all the teamwork online. So for example, you can see that all the survey tracks that have been done by other team members, so you don't have to repeat the survey tracks and make your work in vain. So this is one benefit by using the online GIS platform. So today we'll structure our webinar into 4 sections. The first section will introduce how to use the Superpan for your field survey, including how to use how to apply different base maps from various sources, and also how to collect data during the fields. And also in the next section, we are going to introduce how to build up an online GIS platform for all your team members to manage all the data online and edit the data through the cloud technology. And after you are back from the field survey, you may want to increase the data accuracy you collected during the field survey. So you can use the GNSS extension in the Superpan, and also use the DGPS add-on in the SuperGIS desktop to post-process your data to increase the accuracy. And for the last section, we will introduce some of the useful tools such as spot signal display and laser rangefinder in the Superpan to help you with your field work. So in the first section, we are going to introduce how to use Superpan for your field survey, including applying base maps and using GPS signals to record the location of your point of interest. So to use the Superpan, we are going to introduce a lot of different extensions today. And to activate the extension, you have to go to the setting page and find the extension you want to use. For example, we are going to use Advanced Attribute Editing and Data Service Toolbar and the Online Map tool and the STC layer and other extensions. So you have to activate all these extensions and then restart your Superpan to make them work. So the first thing we're going to do now is to add the base map from different sources, including the online map or STC map, which is SuperGIS tile cache map you provided using the cache generator in the SuperGIS desktop. So if you use the online map tool, you can add the OpenStreetMap to your Superpan as the base map. But if you don't have any internet connection in the fields, then you can generate your own base map by using the catch generator, which is this interface here in the SuperGIS desktop. You can design the map in the SuperGIS desktop and define your own scale and the map extent and the quality of the map. So you can generate your own base map and add it to the Superpan to help you facilitate your field work. So after you have applied the base map, you're going to collect the data in the fields. So you can use the GPS signals or the edit tools to help you edit the data. And also you can use an advanced attribute editing to help you build a custom menu, which is shown here. You can select the field value by using the drop-down menu here, and you can use this to build the customized menu. So before editing the data, you have to enable editing by clicking the icon here, the pen icon here, to enable editing. And then you can also use the advanced attribute editing function to build the menu to help your field survey. So in this section, let's have a short review. We're going to use the Superpan to add the base map from various sources, including the STC layer or the online map tool. And then we are going to collect data by using edit tool and GPS tools. And the last one, we are going to use the advanced attribute editing to build a quick form for your field survey. So now let's go to our Superpan. This is the interface of a PC Superpan. So the first thing we're going to do is to use the online map tool to add the OpenStreetMap as the base map. So we click this map layer icon, and the online street map will be added to your Superpan. So this is the online street map, and then we can use the tools here to pen to our study area. This is actually the Yellowstone area. So if you don't have if you don't have any internet connection during the fields, you may not be able to add the OpenStreetMap as your base map. So you can prepare your own base map, which is the STC layer. So we go to the add layer function to add the STC layer we have generated from the SuperGIS desktop. So this one is the layer we generated from the SuperGIS desktop, and this is the base map for our field survey. So now we're going to introduce how to edit data by using the edit tool here. But before editing the data, we have to go to this layer manager to enable editing by clicking the pen icon here and click OK. Then we switch to the edit tool and select the point tool to add a new point. So for example, now we see there's a gray roof here, so we pinpoint the location and click yes, and then we can type in the name and select the data from the menu here. So we click OK. So then we are going to use the GPS function to demo the GPS function, how to show how to add the data by using the GPS signal. So this is my Superpan installed on a Windows mobile phone. Now we're going to demo how to use the GPS signal to add the data. Okay. Don't show again. All right, let's go to the edit tool, and you will see now we have turned on our GPS function by using the icon here, and then you will see that the GPS function has been enabled. So we can click this icon to add a point using the GPS signal and click yes. Now we have to type in the name, the category. So for example, now we spot a white roof here. So we type in white roof, and then we click OK. And now you can see that there's a point being added to the superpath here. Now you have seen that if we add a new point in the superpath, we have to type in or assign its field value in the field survey. So how do we build the custom menu to help us facilitate the field work? So we use the advanced editing attribute here and select attribute setting and select the layers we are going to set. So now we are going to use this category to turn it into a menu type and click OK, and then OK again. So wait, let me show you another one. Maybe this one then. Oops, sorry. Again, we select it as menu, and then we have now built a menu with 0 options now. So we can add an option by clicking the icon here and assign a new menu, a new name. Maybe it's the name of the surveyor. Maybe it's George. It's me. And maybe I am the one who are always doing the survey, so I set myself as the default value. And sometimes maybe Sarah will be helping me doing the field survey, so I select Sarah. And then we click OK and OK again. So now we see how this works. We're now going to add another feature by using the point tool here and click yes. So now you see that my name is being set as the default value in the name field. So whenever I add a new feature, the value of the name field will be set as George by default. But if I can select the value, another value, for example Sarah, by using the drop down menu here and select Sarah and click OK. So this is how the advanced attribute editing works. So in this section, let's go back to our PowerPoint. In this section, we introduce how to use the STC extension and online map tool to add the base map from various sources, including the online map tool, online stream map, and OpenStreetMap, sorry. And you can prepare your own base map by using the SuperGIS desktop. And then we introduce how to collect data by using the GPS signal and how to build a customized menu by using the advanced attribute editing here. And in the next section, we are going to introduce how to build an online GIS platform for you and your team members to manage all the teamwork online. So in this session, we are going to build an online platform using the SuperGIS server. And during the fields, we are going to download the data from the server to the superpad. And then after the field survey, we are going to synchronize the data back to the SuperGIS server and display it to all the other team members. So the reason that we are going to download the data to the superpad is that if we don't have any internet connection and we have to work offline, then we have to download the data to the device and edit the data on the local machine. And then whenever we are back to the internet, we can synchronize data back to the server and display it to other team members. So if we can display all our, for example, the survey tracks, we can show our other team members that where are the survey tracks have been done, so they don't have to repeat our survey track again to make their survey in vain. So in this section, we are going to use the superpad to use the data service tool to download the data from the SuperGIS server, and then after the field survey, we are going to sync the data back to the server again and display it in real time. So now let's go back to the superpad again. Now we are going to use this data service tool to add the data from the SuperGIS server. Select Add Data from SuperGIS server, And then you have to type in the server connection, the server address, and the login account. Click OK. Then you'll see the root of your service. For example, this one is the service we are going to use. You can see that it is an editable service, so you can edit the map by connecting to this service. Click OK. And then the data from the server will be downloaded to the Superpan. So these are the data, including the lines here and the polygon points here. So let me show you how the online GIS platform looks like. This is the online GIS platform I have built by using our SuperGIS server, and it is exactly the same as the Superpan here. So you can see that the data from the server can be downloaded to the Superpan and use it for your field survey. Sorry. So now we're going to edit the data in from the server. So we go to the layer manager again to enable editing by clicking the pen icon here again. And then once you click the icon, the data from the server, including the polygon layer, the line layer, and the point layer, will be downloaded to your Superpan for for local editing. So for example, now we are going to edit the track layer. So we enable editing by clicking pen icon and click OK. Then we switch to the edit toolbar here and select the freehand line, the line tool, to draw a new track. Of course, in the field, you can use the GPS signal to record your survey track, but now we don't have any GPS signals now in the office. So we are going to demo by using the freehand line tool here to draw a survey track. For example, this is the survey track we have done this time. This one. Click yes, and OK again to add. So this is the survey track we have been done this time. And now we are going to synchronize the data back to the server by using here Synchronize Data with SuperGIS server. Click here and yes, and all the data have been uploaded. Now let's go to the online GIS platform. Remember that we had already added a new survey track here. So I'm going to refresh the map. Then you'll see this is the survey track that I had just added and uploaded to the server. So so all the data you collected in the fields can be synchronized back to the SuperGIS server and displayed the data in real time. So people, whether they are in the office or at home, they can see all your data in real time and manage all the survey, all the teamworks in this on this online GIS platform. So it is very convenient for your management and for your field survey as well. So let's go back to the PowerPoint again. Okay, let's have a short review. In this section, we introduce how to download the data from the SuperGIS server for your offline editing, and then after you have finished your field work, you can synchronize the data back to the server and display them in real time. So this is for this section.
Okay, welcome back everyone. According to the poll survey result, there are around 40% of us are using Windows Mobile, but another 40% are using smart apps. That means we have right and good target today for the Windows users. And the good news is that our next webinar will for smart app users. Okay, now let's go to the second part of our presentation today. We are going to talk about how to enhance the accuracy of the survey data. As we know, like most of the Windows mobile handheld devices have the accuracy averaging around 5 to 7 meters under some good conditions. So many of our users request us to have some solutions to enhance their data accuracy in a cost-efficient way. They don't want to purchase very expensive but very good hardware, something like RTK or very high-end GPS devices. Especially for the users in South or Latin America, they may not have the entry real-time solution for the GPS accuracy solution. So we come up with the GNSS extension of our mobile GIS, and then you can come back to Office by using our data software to process the differential GPS by post-processing. And then you can, in our test, the accuracy would be from 5 to 7 meters to around 7 meters under very good weather condition in an open sky. So let's welcome George again to show us how to achieve that.
Okay, hi everyone, it's George. And in this section, we are going to introduce how to post-process your data to increase the accuracy of the original survey data. So to use the post-process function in the SuperGIS desktop, the first thing you have to do is to enable the GNSS extension to collect the data by using your Superpan. And after you are back to the office, you can copy the data you collected in the fields to your desktop, and then you have to also download 2 additional information from the IGS base station websites and download the data to your desktop to post-process the data and increase the data accuracy. So imagine now we're going to collect the data, including polygons here and the areas here. So why do we have to collect a high accuracy data, especially when we are doing the survey in the urban areas? There are a lot of handmade, human-made features where they are very close to each other. So the accuracy of the location accuracy of the feature, human-made feature, are especially important for the urban field survey data. So for example, now we are going to collect the data here, the areas here, the polygons here. So the figure on the right may be the result we get from the field survey. We can see that the accuracy of the data is not as high as we imagined. Now there are some arrows. And then we can use the data post-processing function of the SuperGIS desktop to increase the data accuracy. And then the result could look like this. So which is almost exactly the same as the reality. So you can use the post-process data, post-process function in the SuperGIS desktop to help you increase the accuracy of the data, even though your original data is limited by the GPS hardware. So in this section, we are going to use the GNSS extension in the Superpan to collect data during the field survey. And then after we are back to the office, we can use the collected data and the information from the IGS base station website to post-process data and increase the data accuracy. So in the Superpan, we have to enable the GNSS extension to collect the data, including log data, Rangefinder data, and also the field, the feature data. So this is the interface of the Superpan, of the GNSS interface. We have 2 functions here. One is for the settings, one is for the recording. So in the setting page, we have to set initial time for GPS initialization. So why do we have to set this? Because when we first start the GPS, their signals are relatively weak. So we have to wait for a while to for the GPS to get more signal and have a higher accuracy data. So for example, we set 120 seconds, which is 2 minutes. So after we click the stop button, the GPS will start recording after 2 minutes after the waiting time. So after the field survey, we can copy the raw data from the Superpan to our SuperGIS desktop for the data post-process, including the DGPS data, the position data, Rangefinder data, speed data, and also the features we collected in the fields. Okay, so in addition to the data from the mobile device, we have to download 2 additional data. One is the navigation data and Rangefinder data from the base stations. So here are a list of the organization that have provided the base station information, and this one, the SOPAC, have provide us the data in the Rhinex format, which is used by our SuperGIS desktop. So you go to one of these SOPAC website to download the data, and then to download the data, you have to find which base station to use. If you don't have your own base station, you have to go to this IGS International GNSS Service website to find the nearest base station, and it is recommended to use the base station that is within 1 degree or 100 kilometers to your location. So, for example, if you are based in Brazil, you can use this base station to perform the post-process. So in this section, we are going to use Superpad to use the GNSS extension on the Superpad to collect data, and then we copy all the data to the SuperGIS desktop to use the differential GPS add-on to perform the data post-process and increase the accuracy of the data. So we're going to demo how to use the SuperGIS desktop and the differential GPS add-on. Let's switch to our SuperGIS desktop. So, for example, this may be the data we collected from the fields, the red polygons here. So we can see that the accuracy is not as high as we imagined. So we can then use the DGPS add-on here to start post-processing. And then we can see in this window there are two sections here. One is the reference station section. The other is the observation data section. So in the reference station section, you have to put in the data you downloaded from the IGS website, including the Rhinex file and the navigation file. And then in the observation data, you have to put in the data you collected from the fields, which is copied from your mobile devices, including the DGPS data and the Rhinex file, navigation file, and position file and speed file here. So all this file comes from your mobile devices, and also the most important file is your target feature. So for example, our target feature is here. Let me locate my target feature in the post process. This feature, which is the original data here, and click OK. And once you click OK, the SuperGIS desktop will start post-process your data, and after it is done, it will ask you to add the data to the current map, and click Yes. So we have to assign a coordinate system, which I believe is WGS 1984. Click OK, and OK again. So now you see this is the post-process data, and its accuracy is higher than the original data, and is almost exactly the same as the reality. So if your data collected by the GPS is not as accurate as you think, you can use the DGPS function to help you to increase the accuracy of the data and get a really high accuracy data. Let's go back to our presentation again. So in this section, we introduce how to use the GNSS extension in the Superpad, and then also how to use the differential GPS add-on to post-process the data to get a high accuracy result. And for the last section, we are going to introduce two useful tools in the Superpad to help you facilitate your fieldwork. The first one is the spot signal display, which is the short for satellite-based augmentation system. It's kind of like the DGPS function, but the DGPS function helps you to post-process data after you are back from your field survey. But if you are using the spot signal, then you can collect high accuracy data in real time. So, for example, if you are in one of these regions, the WAS region or European regions, you can receive the spot signal and use the satellite-based augmentation system to help you increase the data in real time. So in the Superpan interface, you will see a plane icon, an airplane icon here if you enable, if you are receiving the spot signal. So if you see this plane icon, which you can believe that your data is coming in high accuracy. And the other one is the laser rangefinder. It can help you to use a laser beam to locate an object that is out of your reach. So for example, if you spot a wild wolf in the field and it is too high to reach, or it is too dangerous for you to reach, then you can use the laser beam to locate your target, and the location of your target will be added to the Superpan, for example, the red icon here. So we support two laser guns, including the laser craft, contour, and the true pulse. So you can use at least two tools to help you to locate the targets that is out of your reach. So today we have introduced how to use the Superpan to help you perform your field survey, including how to add the base map by using the online map tool, the STC extension, and also how to build a customized manual for your field survey by using the advanced attribute editing. And also we have demo how to download the data from the SuperGIS server by using the data service tool. And then we also introduce how to use the SuperGIS server to build an online GIS platform for all your team members to collect, to manage all the team data on the platform. And the last thing we have introduced is how to use the SuperGIS desktop to post-process the data and help you get high accuracy data. Thank you. This is for today's webinar.